today, what I want to do, we're going to expand upon the same concepts that we have been talking about. Okay, so that means that we're going to still be talking mean, standard deviation, median, IQR, all those kinds of things. Okay, now we're going to start adding to that. We do have one graph left to learn how to do. And so we're going to first identify how transformations. So we're going to identify how changes affect mean, median, IQR, standard deviation. Okay, then we're going to talk about the last kind of graph, which is the last graph that we're going to be talking about is that's real nice. Okay, a cumulative frequency graph. Okay, so that's the last one. All right, so the first problem that I want to actually talk about is in your homework, but I just want to show it to you as an example of what kind of thing we would want to be referencing. And so here I want to look at this problem right here that you will be doing on your homework today. So this problem is about a small health clinic that employs nurses with the salaries of $19,000 to $48,000. And so we want to talk about what would happen to the finances of the company if you raised the salary of each nurse $1,000. So we want to talk about what happens to the average salary, what happens to the median, what happens to the IQR, and what happens to the standard deviation. Okay. So we're going to talk about how adding $1,000 affects those four things. So let's address that first. We will do that with a picture. So this is a concrete picture to help that. So first, this is a histogram that is turned into a curve. I want to show you that this is the average salary. So if you think about each one of these lines being a nurse at that company whose salary is the average, okay? Then you're going to have some nurses with a salary that's a little higher than average in this range, okay? So you don't have quite as many. And you're going to have some here. You're going to have some that are one standard deviation up. Okay, so you get the idea. This curve is made from these histograms and how many standard deviations the nurses are away from average. So the middle is the average. All right. Now what I want to do is look at what happens when they shift. So here we go. I'm going to add $1,000 to their salary. Here we go. Okay. So you can see that the average is now here, and all of their data is shifted up $1,000. So what is the new mean in relationship to what it was? It's $1,000 higher. Very good. All right. Now let's look at this in terms of a box plot. If I had a box plot, and if it's a symmetric curve, then my box plot's also going to look symmetric. Okay. All right. So here's all their information. I'm going to draw another color on top so I can shift things around. Okay. So this green box is going to represent the data when you add $1,000 to each salary. So here we go. Watch the median. Line in the middle, and we're going to shift to $1,000. So what happens to the medians? It increases $1,000 as well. So in summary, this is what we have going on. So on your piece of paper that is pretty blank, it says transforming notes, and the first thing says shifting, adding and subtracting affects. So here's what I want you to know. Here's how it affects the center. Mean and median also shift up or down. That's to the right or to the left. So we're thinking number line here. So that's the first thing on your notes. The mean and the median also add or subtract. Okay. So now let's talk about the interquartile range and the standard deviation. IQR, okay, so IQR and standard deviation are measures of spread. Okay, so let's get this straight here. Mean and median are measures of what? The center. Good. When would you choose mean over median? We choose mean if the data was pretty symmetric. How about median? When would you want to choose median instead of mean? If you have outliers or if you have skew. Good. Now, your IQR, that's your interquartile range, your middle 50%, and your standard deviation are measures of, here it is, spread. They are a measure of how much things are spread out. So, I want you to pay attention to the spread on this picture here. I'm going to shift the data $1,000 up and look at what happens to the spread of the data. Okay? Did the spread, how much it was stretched out, get bigger? No, it did not. Shifting the data from here to here did not change the size of the standard deviations. So the standard deviation stayed the same. Let's do that also with our box plot here. Okay, so here's the green. Let's go ahead and shift it up. Did the interquartile range change in size? No, still the same. So in summary, the spread, which is the standard deviations and the IQR, do not change the shifting. So this is still under the shifting problem information. So on shifting, standard deviation and IQR do not change. They're just shifted up or shifted down. Actually, they're not yet. They stay the same width. Okay. So on your notes, the next thing is dilating. That's like stretching by multiplying or compressing with division, or by multiplying something less than 1. Okay. So let's do that with our pictures. So let's say, I do know on your homework, that's represented in this problem here. Look, let's suppose that the nurses get a 4% raise. Okay. So question, does everybody get the same amount of raise? No. If you make more, then your raise will be larger amount of dollars. Okay. It will still be 4%, so the percent is the same, but the actual amount of dollars is different. Now let's talk about this. If you have $20,000 salary, what am I going to do to figure out my new salary? Okay, so I do get this. I get people multiplying it by 0.04 and then add it to your original $20,000. Okay, good. But I want to show you this in one step. Watch. 1.04. If you multiply by 1.04, then you've got your 20,000, which is accounted for by this 1. So you maintain 20,000, and then you've got the 4 percentage points on top of that. So now you have one step, and you don't have to do 2. Now, what happens if I decrease your salary by 4 percentage points? Then I'm going to take this, and I'm going to multiply it by what? 0.96, because it will not maintain its 100%. It will be 4 percentage points less. So that would give you the value. You don't have to multiply it by 4% and then subtract. Okay. So keep in mind that a percentage change is a multiplication factor. That's the point for that little discussion there. So that when we go to your notes right here, and I say, I want to increase their salaries by 4%, here we go. Watch, it's a visual thing. Here we go, increasing their salaries by 4%. Here we go. Okay? So their salary, the average, does increase, correct? Okay. How about the standard deviation? Because I would be doing mean and standard deviation. What happens to it? It also stretches and gets larger. So let me show you that again. Okay? So I'm going to multiply by 1.04, and I'm going to get a larger mean and a larger standard deviation. Let's look at the box plot. Okay, so here's my box plot of the same data. I'm going to take it and multiply by 1.04. So there we go. So my median is larger. How about my IQR? It is also larger. So in summary, dilating affects center and spread. So the mean and median are dilated. Standard deviation and IQR are also dilated, stretched, multiplied, whatever. Okay, maybe you don't like that word dilated. You'd rather say multiplied, divided, whatever. So center and spread are affected by multiplication. Okay, so let's do the first two problems on your homework. Up here at the top. To the notes, yes. Here's those notes. Okay, so let's do those two problems. Here we go. All right. So the first question is to describe the effect on mean and median, range, IQR, and standard deviation. Now, why did I group those together like that? Mean and median are representation of center. Very good. Range, IQR, and standard deviation are measures of spread. Very good. I know that sounds kind of like a basic thing to talk about, but it helps in understanding when questions ask you something, what you're looking at. So here we go. What happens is $100 is added to each value, then what will happen to the mean? Good. It will increase by $100. Okay. What's going to happen to the median? It will increase by $100. About the range. The range will not change. The entire values shifted, and the high and the low are still the same distance apart. What about IQR? The middle 50% is still the same distance apart, and the standard deviation, all the values are still the same average distance away from the mean. So no change. Okay, very good. So just the center was affected by adding. How about this? Each piece of data is first multiplied by 5, and then you add 2 to each value. So what's going to happen to these measures of center? I'm going to just group those together so I can just write it once. What's going to happen? How will they be affected? They will be multiplied by 5. Is that it? What? Oh, and, good. And you will add 2 and 2 for both the mean and the median. So you just take the current mean, they tell you, and multiply by 5, add 2, and there's your new mean. Okay, how about these measures of center? How will these, these measures of spread, range, IQR, standard deviation, how will those be affected? They will also be affected. So how so? Multiply by 5 only. You will not add 2 to the range, IQR, or standard deviation, okay? Because spread is only affected by the multiplication. Okay, good? So there's your transformation. So your homework on this concept is number 3, which takes an original box plot, and then you are instructed to create a new box plot, and then which will be box plot A and then box plot B. And then you'll also answer the questions for part 4. All right, so let's go to the next set of notes. This is the final graph that you will learn how to do and how to represent our data. It is called a O-guide, but we don't really call it that so much. We actually reference it more as just a cumulative frequency curve. the important thing about this cumulative frequency curve is that the labels are really important that you pay attention to them, because one little word can change the whole representation of the data. One little word can change the whole representation of the data. For example, if you say relative frequency, then that is actually relative to the whole. So that is then a percentage. So if they say here is a chart of the relative frequencies, then they're actually representing the percentage of the whole. Because that word relative is making that. If it's just regular frequency, then that is going to be in actual counts. How many days, how many cars, how many pigs, I don't know, whatever. Okay, and finally, this word cumulative also affects how you read this graph. So of course cumulative, you probably know what that is. See, next week we're going to have a 7-week cumulative test of all of this, everything so far. And so what is that going to include? Everything up to there, up to then. So everything up to a particular place or whatever. Okay, very good. So first, let's look at this chart. This chart is about 50 final exam scores in elementary statistics. On the left, I see I have cumulative, relative frequency. So that means these numbers on the left are what? Percentages up to the whole. Okay? So, and you can see, look, when I end, what am I ending at? 100%. So I then have accounted for all 100% of the pieces of data. Alright, so down here is the score, so the points on the test. Alright, I would like to reference this point right here. Go down here, it's probably about at 63. So my first question is, for a verbal or, in context interpretation of what this point 6320 means. Say it. Ooh, very good. So most people miss that last part of your sentence, but you did get that, so very good. This means 20% of the students, because the Y value is the percent, the cumulative percent. So 20% of students scored 63 points or lower. They did not all score 63 points. They scored 63 points or less. All right, very good. Now, cumulative frequency chart, a relative frequency chart has very good ease of percentiles. So, for example, if we are asked to find the median, where is the median in location of the data? In the middle. So that's at the 50 percentile mark. So find that. Find what score is in the 50 percentile. So I think it's probably about 77, 78, somewhere. So we're just going to kind of do a little squiggle. It's kind of difficult to tell exactly what. And that's 78 points. That's a score, so that's 78 points. Now, how about this one? What percent of students scored below an 85? Okay, so let's find that. So here's 85. It's probably a little more than 70, probably 73-ish or something. I don't know. That's just my guesstimation. You could be a little off. So I said 73% of students, approximately 73% of students scored 85 or below 85. All right, how about this? What percent of students passed the exam? So what do you want to call passing? Okay. In fact, I'm getting too many lines up here, so I'm going to go ahead and erase some stuff here. so we can do this. Okay, so let's call 70 is passing, so that's here. Okay, so I need to be 70 or higher. So this is the section I'm interested in. Okay, so how do I find out how many that is? Or how many percent that is? Good. Let's find, what does this mean? If I line this up right here and I bring this over here and it's about 38%, what is that a representation of? How many people failed? Very good. So I kind of make myself a mental note that 38% failed, which means then 38% failed, then 62% passed. Good. Okay. So you're taking that whole amount and you're knocking off this bottom 38%. Okay, good. All right, now I'm going to give you a few minutes. I want you to identify the 25th percentile, the 75th percentile, because that's your IQRs, by the way. Oh, no, that's your Q1 and your Q3, sorry. And your 90th percentile, and then find the IQR. So I'm going to give you a minute to do that. Okay, so let's go ahead and take a look at that. I approximated these values here. 65 points for the 25th percentile, about 87 points, and yours might be a little off from mine, and that's fine. And then about 94 points for the 90th. To find the IQR, that was Q3 minus your Q1, so I just subtracted the values I had gotten above, and I said that the spread is about 22 points. Okay, any questions there? All right, now, although this is like 3-point font, it's like so teeny tiny, I want you to take a look at this. Now, let's identify the labels first. This says cumulative proportion. So do you think this is in counts or is this in percentages? I think because it says proportion, that is like proportion of the whole. So this is in percent. And this is your GPA, your grade point average. And see, and look over here, you can see this is 1.0, that's 100%. Okay. All right, so I want you to figure out 26 and 27 real quick, and we'll meet back with those. Oh, I also want to see if you can identify if there are any outliers to this data. Okay, so try that. Okay, so what did you come up with for your median? 2.4 is correct. It's at the 50th percentile. You are here at 2.4, so very good. Now, how about the IQR? We're addressing what? Okay, so the IQR is 1. Good. How so? Your Q3, or Q1, sorry, is Q1 is 1.8 and the Q3 is 2.8, so that makes it an IQR of 1. Okay, so here's my question. How do I find out if there are any outliers? Okay, you know our typical IQR rule. Do not use the standard deviation rule for this because we're talking IQRs and medians and stuff, so I had people do that on the test, get a box plot and use the standard deviation rule. No, those don't mix. Okay, so we know then that this is 2.8 plus 1.5 times 1, so that's 4.3. So we come over here and we see, is there any 4.3s? So here's my fence. It should top out there at 4.0. So there's the top. Furthermore, we can actually draw the box at the 25th percentile to the 75th percentile. So I'm kind of superimposing a box on top of this cumulative graph. That's how easy it is to represent the percentiles with it. So then here's my whisker going out to there. And let's see where the lower outlier fence is. That would be our Q1. minus 1.5 IQRs, which is 0.3. So our lower fence is like about right here, which almost kind of looks like exactly where the lowest point is. It almost looks like the minimum. I can't really tell for sure because I do not have the data points, but it doesn't appear as though there's any outliers. Okay, so do you see that connection between this cumulative frequency plot and the box plot? That's another thing that's going to be happening this unit, or this like second half of this chapter, is being able to like connect all of these representations together. All right, so very good. Let's take a look at this one. Let's first label the picture because it's very deficient in information. So we first say that below is a cumulative frequency curve for the daily high temperatures, degrees in Fahrenheit, during the aspen ski season. Okay, so these numbers that you see here, 7 and then 20, that's cumulative. So that means there were 13 values between where the daily high temperature was between 21.5 and 20, whatever the number that is, 8.5, can't tell. Okay, so those are the cumulative ones. Now, this is a cumulative frequency curve. What does that mean is represented on the y-axis? Good. The number of days, and then this is going to be cumulative. Okay. All right. What is the x-axis? Yeah, but it's the daily high. Why would that matter in Aspen? Because of what? Yeah, skiing. We want to know approximately how many days are we going to be having, compromised snow and such. Okay, so daily high temp in degrees Fahrenheit. Okay, very good. So I want to take a moment, let you actually answer A through D right now, and then we'll meet back and take a look at those. So do that now. Check and see what we got. So my approximations for the values were these. So I said that's about 40 days that had a daily high of less than 32%, or 32 degrees, sorry. About 20 days and about 132 days. Okay. So I want to know in words what you say in context this point right here means. What does this point right here mean in context? Correct. Very good. So I would expect there to be about, so that's going to tell us the number of days that the daily high temperature is 32 degrees Fahrenheit or less. Okay? So the daily temperature could be 32 degrees or less. And then how many total days were represented on the chart? 179. The graph went up to 180, but how many days right here is 179? Okay? All right, now, this last one. Okay, so how did you figure out how many exceed 46 degrees? So that was from what to what? How many exceed? To me, that's like this section here. Good. So you subtracted. Good. So you subtracted 132 from 179 to get your 47 days. All right. How about this one with the above 60%? Okay, good. What were your values that you subtracted? Yeah. Okay, so that's that little section here. So I actually did 165, but that's, so whatever. So I said it was about 14 days. You might have said just 12. But it asks for it in a percent of the season. So how do I get the percentage then? Good. It's a percent of the whole. So to find find that percent, you divide it out, and that's your 7.8%. Okay, very good. All right. So we're not going to do that last one on the notes. We are actually going to go ahead and take a look at this homework so I can kind of get you started on what it means and the direction I want you to go with this. So take a look at your second page of your homework. All right. So first of all, tell me what this is about cars and traveling an average of kilometers on 1 gallon of gas. So the miles per gallon are actually the kilometers per gallon. Okay. So what is over here on the left-hand side? Regular frequency. So these are counts. So this will be like how many cars were at that point or less. Okay? And so then the x-axis is the kilometers traveled on 1 gallon. Okay. All right. So how many cars were in this experiment? How many pieces of data? 80. Okay, good. So this is data that is out of a total of 80. All right. Now, if you look down here, we are eventually going to be turning this into a cumulative relative frequency. So over here on the left is percent, which means that how much is it out of? Good. So if I'm going from out of 80 to out of 100, what transformation is happening? Am I just going to add 20 to everything? No, it's actually a stretch. Yeah, it's being dilated. It's being multiplied by something. Very good. So we'll end up getting something that looks like the graph up above, but it'll look a little taller and skinnier and more stretched out is what will end up being graphed down here. Now, I want you to use this table here that I started you on the next page. So let's talk through how to fill in these values here. So these are your counts, the actual counts of how many cars. And then this, of course, we're going to then be turning it into percent. So this first bin says how many cars got less than 18 kilometers per gallon. So we go look here, and that's this spot. How many cars get less than 18 kilometers per gallon? Okay, good. So that is 0 right here, which then equates, of course, to 0% of the cars in the sample. All right, next, less than 20 kilometers per gallon. So here we go. That's going to be right here. So how many? 2. So that is 2. Now, that's 2 cars, which makes 2 out of 80 to turn into 2.5%. You see how this 2.5 is a larger number than your 2? Why is that? Because I'm multiplying and stretching it. It is being expanded upon. Let's do this one right here at less than 30 kilometers per gallon. And let's see what that is over here. Okay, good. So I'm going to follow this up. I see that value is 28. So I'm going to say there are 28 vehicles in my sample that have less than 30 kilometers per gallon. So that's 28 out of 80, and that becomes 35%. So once again, do you see how this is a large, in percent, it's larger than your overall 80 when it was out of 80. So once you get all those pieces of data, you now graph it here. So our first one at 18 was at 0. Our 20 was at like 2.5. You would do all of these ones in between, okay? I'm not putting those on there, but you would do those. Our 30 was at 35. So, you know, you're going to end up getting something that I don't know what's going to be. But it's stretched out. It's going to look the same, similar, but more stretched out. Okay? It's going to look similar to what up above. So you will complete that, and you will answer these questions down here. Okay? All right. So your homework then is to finish this page here as well as numbers 3 and 4 on the front. And that's it. Now tomorrow I will not be here, but you will get your stamp sheet, and the substitute will stamp you, and then you're also going to